Math 1, 8.4, compositions of transformations homework. All right, so this is not really new what we're doing today. All we're doing is we're taking two different transformations and we're doing them on one pre-image. So let's take number 1 together. In problems 1 through 6, describe in words the transformations needed to produce the image, the dotted shape. So what we're saying here is we're starting with our pre-image right here, the solid figure. And what do we need to do to get this guy over here? And it will take two different transformations. It might be a slide and a rotation. It might be a rotation and a reflection. It could be a reflection and a slide. So any combination of two transformations. All right, and sometimes you guys come up with your own fancy ones, but it should be able to be done with two. So we want to get this guy over here. Do we have any ideas?
Reflection and slide.
Very good, reflection and a slide. Now, if you can do it like that and you can see it, that's awesome. If you can't, this is where patty paper really helps. So sometimes it just takes some experimenting. And this is where one of the few times I think, well, let's start with patty paper. So I draw my origin. I make sure I get it on there as close as possible. And then without moving the patty paper, obviously, I'm going to draw my triangle, my pre-image. Be very careful not to let it move. All right, and then I'm just going to experiment. Maybe I try, okay, I think maybe rotate 90 degrees. And then, no, that's not good. Maybe if I had to flip it. So, I go back and, okay, let me see. What if I did a rotation, or excuse me, a reflection, and then, oh, look at that, a slide. There it is. Or some of you might have said, okay, what if I do a slide and then a reflection? And really, that's up to you. But I think probably the easiest is to do a reflection over the y-axis and then a slide down, looks like 3. Down 1, 2, 3. So a reflection over the y-axis and then a slide of 3 or a translation of 3. But what we want you to do is write it. And so a lot of times it takes 2 steps to write it. So the first thing is we want to show the first transformation, which in this case is a reflection. So we write xy. And what happens, what do we do when we do a transformation over the y-axis? We said that when we do a reflection over the y-axis, the y stays the same and the x becomes the opposite, right? So that means the x becomes the opposite, the y stays the same. Okay, so basically what we did so far is we went from here to here. Now we need to do our translation of down 3. And when we go down 3, what we do is the x is going to stay the same and your y is going to be minus 3. So we want to do it in one step, so it's just xy becomes negative x y minus 3. And that's it. We wrote the rule. Okay? All right, I will do one more with you. Which one you want me to do? What's that? 2 through 6. Which one? All right, I heard 3. That's the one. All right, so 3, we're going to move this guy from here up to there. It looks like maybe we could do a 180-degree rotation, or maybe we could do a reflection, I don't know. So let's draw it. So the first thing I'm going to do is I'm going to take my patty paper and I'm going to draw the original or the pre-image. Make sure that patty paper doesn't move. Alright, so what if I did a, oh, look at that, a reflection. Okay, and then maybe I could go to the left, looks like 3 and up 2. Oh, look at that, that was too easy. What if you tried a rotation of 180 degrees, what would happen? Oh, that looked like it, but no good, huh? Because that's definitely not going to get us there. So it looks like we're definitely going to do a reflection, right? We're going to do a reflection over the x-axis. And then we're going to translate it 1, 2, 3 to the left and up 1, 2. All right, if you have to do it in 2 steps, you can. So first I have my x and my y. That's where I'm starting. Any xy on the pre-image would first we were going to do a reflection over the x-axis, which means the x stays the same and the y becomes the opposite. And then we said we have to go 3 to the left. So now we're working off this guy. So x minus 3 and negative y, we set up 2, so plus 2. So to go right from here to here, we would go xy becomes x minus 3. Oops, I shouldn't have put that. That was supposed to be a comma there. X minus 3, comma, negative y plus 2. Now here's the great thing. Let's take this point right here. It's at 4, negative 3. And let's just see what happens. 4, negative 3. And if we apply the rule, so 4 minus 3 is 1. And negative 3, first of all, negative 3, what's the opposite of negative 3? 3. And 3 plus 2 is 5. So this guy should become 1, 5. Let's see. 1, 5. Look at that. He's right there. So the rule works. All right. So you're going to you're going to figure out what the it's called a compositions of transformations, meaning what the 2 transformations are for those other 4. Let's flip it over now. And let's see what's happening here. For problems 7 through 12, in each of the following transformations, write the coordinate notation. Example, reflect about the y-axis, then translate up 2. So xy becomes negative xy, then becomes negative x, y plus 2. So they don't even mind if you do it in 2 steps. All right, so I'll do number 7 for you, and then I'm going to kind of turn you loose here. So number 7, they want you to translate 5 units to the right, then rotate 90 degrees counterclockwise about the origin. So first we take care of the translation of 5 units to the right. Well, if we're going to go 5 to the right, then we have to add 5 to x, don't we? So xy becomes x plus 5. The y is not going to change. Okay, but then we want to do a rotation 90 degrees counterclockwise. So when we do a rotation 90 degrees counterclockwise, first we switch our x and our y. So the y is going to become our x, and our x becomes our y. But it's counterclockwise, so we switch them. Now remember, counterclockwise means this way, so your new x becomes the opposite. So we just put a negative right there. Does that make sense? All right, so I'd like you guys to finish up this worksheet. 1 through 13. I'm not going to do 13 for you. I'm going to leave you guys to figure that one out. You got patty paper? I'll give you guys about, let's say till 9 o'clock to get this done. Ready, break.